Hi guys. So we keep missing B days, so I'm gonna try to do this video so that you can still follow along and keep up with the schedule. I'm trying to fit one more quiz in before the end of the quarter just to boost grades a little bit, so that's why I want to make sure we don't skip any more days. But our new chapter is about hypothesis testing. So hypothesis testing, this is a process that uses sample statistics to test a claim about the value of a population. So just as usual, we're trying to use information from a sample in order to predict for a population. And so here we're trying to make decisions about whether a claim is correct or not, or if we could prove it wrong. So if we claim that's, the mean of something is this number, we want to be able to see if that's right or not. So like in science, before we start any study or a hypothesis test, we start with our hypotheses, and we write two of them. One is called the null hypothesis, the other is called the alternative hypothesis. So we're basically either trying to prove one or the other is correct. So these are always going to be opposites of each other. So the null hypothesis, we use the symbols H with a little O for. The O kind of stands for like original. So null hypothesis is how we read it. Sometimes I might say HO for short. But it'll always contain a statement with certain symbols in it. So we either use an equal sign in our HO, the null hypothesis, a greater than or equal to sign, or a less than or equal to sign. So basically the HO is always the one with some sort of equal sign in it. A regular equal sign, a less than or equal to, greater than or equal to, less than or equal to, but it has to have that equal sign. The alternative hypothesis has to be the opposite. So we use the symbol HA, A for alternative. And since it's always the opposite of HO, for the equal sign, if I use an equal sign in HO, then the opposite of that would be does not equal. So an equal sign with a slash through it. That's the opposite of equals. Greater than or equal to, the opposite of it would be less than. Because if you're not greater than or equal to it, to whatever number, then the opposite would be less than. And so greater than would be the opposite of less than or equal to. So basically, anytime you use like a less than symbol, then for your HO, it'll have to be the greater than or equal to. So here's how we basically use this hypothesis test. Let's say a manufacturer that advertises its new hybrid car has a mean gas mileage of 50 miles per gallon. We suspect that they're over-exaggerating the gas mileage. So, when companies are trying to sell their cars, they're going to try to get you to go off of their high gas mileage. That way you save on gas a little bit. But if we think they're over-exaggerating, then we won't actually get the gas mileage that they're advertising. So what we want to do is test a sample of cars. We could measure their gas mileage and then find the sample mean. And then once we've done that, then we can kind of see whether the difference between what we got in our sample actually matches with their claim. So they claimed 50 miles per gallon. So we want to see if the difference in our sample mean is between our sample mean and the claim mean is by chance. Because by chance would be like, it was just a fluke. Maybe we got a bad sample or something like that. So if it just happened to be that we got a bad sample and that's why our mean was so much different than the 50 that they claimed, then we know then it's probably okay. But if it's not by chance, then maybe we are right that they are over-exaggerating. And that's what we're trying to figure out. So in order to do this, we're going to calculate some probabilities. We're going to assume that the add is true. And then we're going to use our normal probabilities, so our normal curve, to calculate the probability, which means we're back to our pink charts. And then do you guys remember if your probability was smaller than 0.05, then it's considered unusual? And that's basically the rule we're going to use here as well. If the probability is less than 0.05 for whatever we calculate, then that means the chances of whatever we got happening should have been like pretty rare, because that's less than 5% chance, so it shouldn't really have happened. So that's how we prove that the add can't be true, that they were over-exaggerating. And that's kind of our process that we want to do. I'm not going to do the entire process together today, so that's why I'm splitting up 7.1 into day 1 and day 2. I kind of just want to start with the hypotheses, because that's like our first process, our first step of the process. So I want to practice writing the null and alternative hypotheses for each situation. So here, a school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. So we're trying to write our null hypothesis and our alternative hypothesis. So here they give us 61% as our number. So since they're giving us a percent, then the symbol that we should be using is P. P for percents. Remember our proportions. And then in our hypotheses, we always use the same number for the null and the alternative hypothesis. So I'm just going to turn that 61% into a decimal, so 0.61. And then this word is. Is means equals. So if I look back up at my list of symbols, equals is the one that goes with HO. So in HO, I'm going to put an equal sign. HA is supposed to be my opposite, so if equal sign is what I use, then the opposite would be does not equal. And so my HA then will have to be does not equal. And it doesn't matter which order they tell you or like which symbol they tell you, it always has to be these ones go with HO, these ones go with HA. So like for the example, the second example, a car dealership announces that the mean time for an oil change is less than 15 minutes. So 15 is the number we're using, but they told us less than. So for my HO and HA, I know I'm going to be using the number 15. And then since they told me less than, in my list of options, less than is this symbol right here. The less than sign is supposed to go with HA. So for this one, I'm actually going to know the symbol for HA first. And then the opposite of less than would be the greater than or equal to, and that always goes with HO, so that's how I know it'll go there. And this one, they told me it was a mean. So if you remember back in the day when we talked about a population mean, it was mu. So that's the one we're going to use. So we'll mostly be seeing P's and mu's for all of our hypotheses. So this next one, a company advertises that the mean lifetime of its furnaces is more than 18 years old. So 18 is our number. They told us more than. So more than is greater than. So that's an HA. We'll go for this one. And then the opposite would be the less than or equal to. And it was a mean, so it'll be mu again. Cool. Okay. So then we want to talk about how it's described. So left-tailed, right-tailed, and two-tailed tests just means look at your HA. If your HA had a less than sign in it, this counts as left-tailed, because basically in a normal curve, when you saw the less than sign, you knew you were shading to the left. And so that's how you'll know. If HA had a greater than sign, that means you're going to be shading to the right, and that's why it's called right-tailed. Two-tailed is for when you're using a does not equal to symbol. Because when it's does not equal, we don't really care whether it is less than or greater than, so we actually count both. So that counts as a two-tailed, and so there's like two tails to our normal curve. And that's what we're trying to do. So when we make that decision with our hypothesis test, after we calculate our probabilities to see whether we get something greater than or less than the 0.05, we get to make a decision. So our two options are either to reject our HO or we fail to reject HO. So these are our only two options. If we reject HO, that means HO was false. That claim was not good. That means HA should have been true. We fail to reject HO if we don't have enough evidence to say that HO is false. We never accept it. So just as in real life, we never accept a hoe. Insert laughter here. Thanks. I'll be here all week. All right. So fail to reject HO and reject HO. Those are the only things that we can do. It's kind of like in court. You can only find someone ever guilty or not guilty. You never really prove them innocent. And so this is the same thing here. We either say HO is false, so we reject it, or HO, we don't think that it's false, but we never say it's true, so we never accept HO. But because we are only deciding these two things, what if we make the wrong decision? There's two different types of error, type 1 and type 2. Really weren't that creative when we came up with names for these errors. But type 1 error is when you reject HO when you shouldn't have. And so type 2 error is just the opposite. You fail to reject HO when you should have rejected it. Because we should have figured out that HO is actually wrong. So you should have rejected it. Okay, let's do an example with that just so we can kind of see how that works. So the USDA limit for salmonella contamination for chicken is 20%. A meat inspector reports that the chicken produced by a company exceeds the USDA limit. You perform a hypothesis test to determine whether the meat inspector's claim is true. When will a type 1 or type 2 error occur? Which error is more serious? So we're basically testing if there's salmonella in chicken. This is bad, obviously. That's why we don't eat raw chicken. You got to fully cook everything. But 20% is pretty high, and that's why we have to cook everything, because the limit for actually containing salmonella is actually kind of high. So that's why you have to cook your chicken. So first, before we start, let's write our hypotheses. So our HO and HA. They're giving us a percent, so we know we're going to use P. And so we know the number that we're going to use is 0.20. So they're saying the USDA limit is 20%. A meat inspector reports that the chicken produced by the company exceeds the USDA limit. So if the limit is 20%, we obviously don't want that. We want less than that. So exceeds the USDA limit would be greater than or equal to. And because it's the equal sign, it's got to go in the HA. We actually want our salmonella to be less than 20%, and so that's why I'm putting that as my HA. So type 1 error is supposed to be when we reject HO even though we're not supposed to. So that means if we reject HO, that means we thought that HO was wrong. So we're actually thinking that there's less than 20% of salmonella. Even though there's actually more, because we shouldn't have rejected it. So we said this is wrong, even though it was actually not wrong. So in this case, we would end up thinking that this chicken was safe, even though it's not. That's pretty bad. Type 2 error would have been us failing to reject when we should. So if we fail to reject HO, that means we think this one's actually correct. We're not rejecting it. So that means we think there's over 20% salmonella. Oops. But there's actually not. So in this case, we would be like, oh, this chicken's bad because it's got too much salmonella, so we're not going to sell it or just throw it out or whatever. Even though that wasn't the case, we could have sold it. So in this case, type 1 error is probably worse because you're going to end up thinking that this chicken was safe, so let's sell it. So now all these people are going to get salmonella if they don't cook it properly, and that's worse. And that's pretty much it. So you should be able to get your classwork done here. It goes pretty quickly. I'm trying to show the screen so that you guys can get this done. Pause here if you need to, if you didn't pick up a worksheet. Good luck. Get it uploaded onto Canvas. Have a great day.